Now we are starting the juicy part. We're starting the juicy part where we start the theory of principal component analysis, or PCA. So there are many different versions of PCA. We have standard PCA, incremental PCA, we have sparse PCA, we also have kernel PCA. We're going to focus on standard PCA to develop the theory of what principal component analysis is. So because this is the dimension reduction algorithm, principal component analysis tries to find a low dimensional representation of our data. Right? And it does so by retaining as much variation as possible that is in the data. Because if you're following this as a course, like properly, video by video, you remember there's a time when we said that if you have a column that is gender, or whatever it is, if it's gender, and 99% of that column is males, this column doesn't have much information. It doesn't have much information because it's almost everyone is having the same gender, so it doesn't have much information. But if you have a column like age, that is people from 18 to 90 years old, and they are evenly distributed, is very variable through all instances and stuff like that. This one has a lot of information. We love algorithms love these kind of columns that have a lot of variation in them, right? So that's what principal component analysis does. It loves these columns that have lots of variation because that's where the information is. So as it is moving from a high dimensional representation, it moves to a low dimensional representation, but maintaining as much of the variation as possible. It tries to maintain as much of the variation as possible because inside that variation, that's where the information is. So it does this by addressing correlation. As it to maintain the variation, it does this by addressing correlation among features. If correlation is very high among features, among a subset of features, PCA will attempt to combine the highly correlated features and represent this data with a smaller number. So let's say we have 20 highly correlated features. It will try represent the information or the variation in this 20 with, let's say, five linearly uncorrelated. So it tries to get rid of the correlation, but by doing so, it reduces the dimension and correlated features. So now these features are no longer correlated. It has picked that 20, and then it boils it down to 5 uncorrelated features. It keeps doing this. It keeps checking again. Are there some more that are correlated? Yes, there are some more. There are 30 more. Okay, cool. When it gets those 30 more, it then it gets those like 20 more, whatever it is. It then puts into another set of uncorrelated features. It's going to be it then uses these as the new sets of features. I'm going to show you how. These newly derived components are known as the principal components. So after it has moved from high dimension to low dimension, the new features that it has are called principal components. So they are not features anymore. These are the features in our original data set. But in the low dimensional space, they are called principal components. What I'm going to do here is, for now, I'm going to stop this video. I'm going to upload 2 videos from my supervised machine learning from first principles. So next two videos, I recorded them months ago, but they're going to explain principal component analysis, and I'm taking them from my supervised machine learning from first principles course. That's where I'm taking them from. So if if what I'm saying in those videos starts confusing you, like, no, but we didn't do this, don't be confused. It's just because I don't want to repeat that content if I already have it. So I'd rather just upload it as bonus videos that will explain exactly what PCA is and give you an example. And I believe that video would make you understand what PCA is. And after those 2 videos, I'll carry on the explanation of PCA using unsupervised learning. So it's still unsupervised learning, but it's just coming from a supervised MO course because I needed to use it there. So those 2 videos, let them not confuse you. I'll see you after the 2 videos.